Hi, this is part 2. Can you read the question very carefully for this question? Okay, again, we need to actually take note that this is actually a distance times graph. Okay, and the y-axis is actually distance. So you want to read the distance, you actually read off from the y-axis or the vertical axis. The horizontal axis will be time. Now, I need to just analyze the question. They mentioned that the cyclist travel at a constant acceleration for the first 6 seconds. So for this one, right, this is a constant acceleration. So we just write constant acceleration. Okay, and for the remaining 6 seconds, it traveled at a constant speed. Now, if it's traveling at constant speed, right, okay, it's still moving forward, okay, because it's still traveling. Now, let me just analyze this question a little step further. Now, if I want to convert this from distance times graph to speed time graph, I know this is done in part C here, okay, but let me just analyze this for you to actually understand the question better. Okay, if this is speed and this is time. Now, what does the question mean is that for the first 6 seconds, right, from 0 to 6 and 6 to 12, right, from 0 to 6 is travel at the constant acceleration. So if I were to draw this line here, okay, it must travel in this manner, okay, because here the gradient is constant, okay, it reflects constant acceleration, whereas here it travels at constant speed. So we know that after the 6 seconds, it must be traveling at constant speed here. There's no here, A will be more than 0, A here will be equals to 0, okay. Now, so what will be the average speed, okay, of this cyclist for the entire 12 seconds? So remember, this is average. So for average speed, right, we're actually going to find the total distance taken or total distance travel, okay, over the total time. And we read off from the graph, this is 90. From 0 to 12, it travels from 0 to 90. So this is 90 meters in total. And the total time is 12. Okay. So if you were to divide 90 divided by 12, you are going to get, I think, 7.5. Okay. So this is the answer. Okay. Now go back to this question, right? I don't know this value, okay? This will be tackled in part C. Now calculate the speed of the cyclist at t equal to 6. Now, what is the speed at here? Now, if you notice, right, okay, this is the speed at the moment when t is 6. So we couldn't say, oh, I take 0 to 30, the vertical distance is 30, and then divide by 6. I can't do this. I can't do this. This is actually wrong. Okay? This is wrong. Because if I were to do this, I'm finding the average speed, okay, across the 6 seconds. This is not what we wanted to do. Okay? Now, what we can do is that we notice that, and this from 6 to 12, right, it's traveling at a constant speed. Okay? The speed doesn't change. Am I right? If I were to find the gradient here, this will be equals to the speed of the cyclist from 6 to 12, including 6 and all the way from 6 to 12, as you can see here. Okay, so what's the gradient? If I were to draw this line here, the change in y, right, from here to here, right, is actually 90 minus 30 equals to 60, and from here to here is 6. So the gradient here is going to be 60 divided by 6, the gradient, right? So this will give us 10. Okay? And this value will be the speed from 6 to 12, including 6. including 6 added 6, therefore this is going to be 10 meter per second. Okay. Now, for part C, we are going to draw the speed time graph. This is speed time graph that we need to draw. We need to convert from here. Now, just now I analyzed that the speed time graph looks something like this, but we do not know what is this value. Okay, let us draw this again. So we know that it is of this shape. Okay, for the first 6 seconds, it is at a constant acceleration. That means it must be this direction. Okay, let me just show you again. Sorry. Okay, and we know that after the 6 seconds, the remaining 6 seconds is traveling at a constant speed. Okay. Now, so what is this value here? We need to indicate. Okay. Now, if you were to take note, right, the value of this speed here is equal to this, because this is actually the speed at time 6 seconds. So we can just place here. Now, we're going to check whether the distance traveled, right, in this speed time graph, which is equal to the area under the graph, right? Okay, is it equal back to this speed time distance time graph here, which is 90 meter? Okay, let's do. Okay, let's try. Let's check whether we are right. Okay, look at this first area. Let's say I call this A1. Okay, and this is A2. Now, what is the area for A1? A1 will be a triangle, right? Half times 6 times 10. What do we get? We're going to get 30. And if you take note, at 6 seconds, it travels 30 meters. Okay. What about A2? A2 is a rectangle. This is 6, this is 10. 6 times 10. This gives us 60 meters. There you are. The total will be 60 plus 30 will give us 90 meters, which corresponds to our distance time graph here. Okay.